Well, hi everybody. Thanks for joining my Tech Talk. I'm going to give you an overview of the formal and simulation verification we're doing at Open Hardware for our Core 5 IP. Before I do that, I should just give you a little overview of who and what Open Hardware is. The Open Hardware Group is a not-for-profit global organization. We have 58 members and partners and growing. We've got an international footprint all around the world. It's really an exciting organization to work with. And we've got strong support from industry, academia, and individual contributors worldwide, helping us develop Core 5 IP. Speaking of the industry ecosystem and our members, these are a bunch of logos that we have for our members and partners. You'll recognize a lot of these. These are organizations that are silicon vendors, design services vendors, EDA tool vendors. We've also got a strong ecosystem from the research community. A lot of organizations you'll recognize here if you've been involved in RISC-V for any amount of time. This is where a lot of the real innovation comes from. And we've got a partner ecosystem as well. People that provide tools, other kinds of expertise. Really fortunate to have all these people helping us to help and working with us to develop these IP. With all these partners, what are we doing? Well, Open Hardware is developing the Core 5 family of RISC-V cores. These are familiar to a lot of people from the Pulp platform team at ETH Zurich. We've got the RISC-V core and the Ariane core, which we've rebranded CVE4 and CVA6. CVE4 is approaching RTL freeze, and we're looking for people to participate in CVA6. So with that, what I'm going to do now is I'm going to transition over to a bit of a discussion of the verification environments themselves. I'll just give a quick overview of the verification task group and what's going on in the verification task group, both for simulation work and formal verification. Just a brief introduction of what the simulation task group is. We're a group within Open Hardware that is focused on verification of Core 5 IP. We're led by our co-chairs, Leo Wong from FutureWay and Steve Richmond of Silicon Labs. And our goal is to develop best-in-class verification environments to fully verify Core 5 IP, make it available to the market. So this whole thing starts with planning. You really can't do verification unless you know exactly what your plan is for verification. So we have lots of verification plans. A key attribute of our verification plans is we have separate verification plans for formal verification and for simulation verification. And that way we understand exactly where things are happening, what's being done in formal, what's being done in simulation. I'll briefly walk everyone through the simulation environment. This thing is developed in UVM, so it's a system Verilog UVM environment. And as I've done in the past, I'll just walk everyone through from your left to your right. The whole thing starts with stimulus that is predominantly generated by the Google Random Instruction Generator. You may know it as RISC-V DV. We've put system Verilog extensions onto that, which we call Core 5 DV, but at its heart, it's the RISC-V DV generator. Programs emitted by the generator are run through the tool chain, and the next part is very important. This is a key attribute of our UVM environment. The program is run on the core and the reference model at the same time. So the same program is being run in two different locations at the same time. And as the program executes, we've got assertions that we reuse from the design team and functional coverage that is really an embodiment of our verification plan that's tracking the instructions that are being executed, the opcodes that are being used, the interrupts that are being asserted, debug requests. All of those things are being recorded in our functional coverage as the simulation is happening. As the simulation is happening, we've got UVM agents, and if you know UVM, you'll know what a UVM agent is. We've got UVM agents driving the debug request and all the interrupts, and these are being done asynchronously from the program that is executing. So we've got a program executing, and that's a random program. We've got an interrupt agent that's generating random interrupts asynchronously to the program. We've got a debug agent that's doing the same thing. All of these events are being fed to the core and to the reference model at the same time. That's a very powerful thing for really bringing out the corner cases in your design. As instructions are being executed, they get retired. As they get retired, they are handed off to our scoreboard, which does a step and compare. We compare all the CSRs, all the GPRs, and the program counter at the retirement of every instruction. So that's a lot of stuff going on, and there's a lot of people contributing to that. How do we keep track of all that, and how do we make sure that everybody on the team is working towards the same goal and moving forward? The workflow that we use is all centered on GitHub. GitHub is the center of our universe. We use GitHub to issue tasks to people. We use GitHub to merge the code so that we're always moving forward. Individual contributors working for individual member companies will use their own compute and their own tooling to execute tasks. And these tasks can be something like write a test case, develop a UVM agent, fix a bug, the kind of usual things that happen in a simulation activity. As that's happening, people are contributing code up to GitHub, issuing pull requests. These pull requests automatically kick off regressions that run on the metrics cloud. And when those results are good and we look like we've achieved the goal of whatever task it is we're trying to achieve, we'll merge things onto the master trunk, and the whole process just keeps going. I was talking about contributors working for member companies. We're really, really lucky, really blessed to have a very large community of contributing members that are actively contributing to Core 5 VERIF really on a daily basis. We've got silicon vendor organizations, academic organizations, design services organizations, all coming in to help us achieve the goal of having best-in-class Core 5 IP available to the market. Talked a little bit about the UVM, the System Verilog UVM environment. Everything we do is in System Verilog. And I'm very pleased to say that on the simulation side, we support all 5 of the major commercial System Verilog simulators. So regardless of what tooling you're using in your organization, you can pick up the Core 5 VERIF environment and it will run on one of these platforms. Okay, achieving the goal. So I get this question a lot. So I just talked a little bit about the simulation environment. Later, we'll be talking a lot about the formal verification environment, and it sounds like we're doing things twice. Why are we doing things twice? Why are we doing things in formal and in simulation? A couple of reasons for that. First is you want to use the right tool for the job. Each technology, formal and simulation, have different strengths. You want to exploit those strengths in the areas where they're most appropriate. You also want to take advantage of concurrent engineering. We've got people doing formal verification on one area of the core and simultaneously while people doing simulation verification on a different area of the core. That way you can get bugs into the hands of the designers as fast as possible. Another consideration is not all open hardware members use formal. Formal is still an up-and-coming technology, so we want to make sure that we have both formal and simulation environments available in Core 5 VERIF for our members to use. And we want to be able to allow members and potential members the opportunity to use whatever tooling they currently have. And that's a very important consideration. Thanks for attending my Tech Talk, everybody. I hope I whetted your appetite for what's going on at the Open Hardware Group and what we're doing in Core 5 verification. If you'd like more information, I'll invite you to attend the talk that I'm giving with Sven Weyer of OneSpin and Steve Richman at Silicon Labs. It's here at the RISC-V Summit. It's on Thursday, December 10th. I believe that's at 12 noon Pacific. And we're going to have a deep dive into all the things we were talking about. We're going to talk about formal. We're going to talk about simulation, give you a real strong overview of what's going on in the Core 5 VERIF environment. Hope to see you there.